Our team, Calc Intelligence, has partnered with Excel for many years. This talk is going to talk about our past work on incubating Lambda and the concepts of Excel as a programming language, our present work on the Lambda Editor, and finally I'm going to talk about some future directions that we're very excited about. We are a team of researchers, engineers, and designers. Calc Intelligence, our mission is to create a trustworthy collaborator and teacher to empower more people to get more value from data. This is our building near Cambridge train station. Here's a photo we're happy about, remembering happy days when we could work together. This is a warm-up exercise for a design jam we were doing on sheet-defined functions, something I'll tell you about later. And it shows some of the Excel team with some of our team having a bit of fun. We have this lovely quote from Dave Gaynor, Vice President for Calc in Office and responsible for Excel. He says, "Simply put, Microsoft researchers are now a core part of the Excel team, helping to create the product's future." Let me tell you about Project Yellow. This is a project to think about Excel as a programming language, and it's been a long-term partnership between us and Excel. This is Bonnie Nardi, an eminent HCI, human-computer interaction researcher. And back in the 90s, she was one of the first people to realize that what people were doing with spreadsheets was programming. She came up with the phrase end-user programming, and that describes programming to achieve the result of a program primarily for personal rather than public use. Amy Coe and others came up with another characterization. End-user programmers are secretaries, accountants, children, teachers, interaction designers, scientists, or anyone who finds themselves writing programs to support their work or hobbies. What are end-user programs like? Well, there was an amazing treasure trove of spreadsheets uncovered in a trove of emails that were placed in the public domain following the legal difficulties that Enron got into back in 2001. So those emails that were made available included about 15,000 spreadsheets. And some researchers, Felina Hermans and Emerson Murphy-Hill, did an exploratory data analysis of those spreadsheets. And it revealed fascinating information about the way people use spreadsheets. They found, for instance, that about half of all spreadsheets contain formulas. That also means that half don't. So, Excel is a very versatile business and presentation tool. People use tables, charts, pivot tables without necessarily writing formulas. So people get a lot done in spreadsheets without writing any code themselves. But on the other hand, half spreadsheets do contain formulas. So it really is a programming activity, building spreadsheets. On the other hand, they found that most formulas are actually pretty simple. So those functions, sum, plus, minus, times, divide, and if, cover half of all the functions you discover in spreadsheets. So the conclusion from this is that most end-user programmers write very simple formulas. These people are not computer enthusiasts. They're not primarily interested in building complex programs for their own sake. They tend to write quite simple formulas. There are ambitious spreadsheets with thousands of formulas in them, sometimes developed over many years by skilled experts. There's a nice cartoon from XKCD about the complexity of programs. You start on the left with something very similar like left pad and quicksort, getting more complicated, Git, self-driving car. But on the far right, we have a sprawling Excel spreadsheet built up over 20 years by a church group in Nebraska to coordinate their scheduling. I think we've all seen very complex spreadsheets. Spreadsheets are code, and spreadsheets are programming languages, but we have to admit it's an unusual kind of programming language. Here's a comparison. On the left-hand side, you've got traditional programming. On the right-hand side, you've got Excel. So on the left-hand side, traditionally, you'd have professional programmers compared to end-user domain experts writing code in Excel. On the left, programmers tend to write code, concentrating on that, not looking at the data, whereas in Excel, data is first, and the code, the formulas are actually invisible. On the left, traditional programming is about edit, compiling, and running. On the right, Excel is always live. You edit the formula, you edit the data, it recalcs at once. In traditional programming, programs are laid out in time. You think about writing loops that iterate over time, whereas in Excel, programs are laid out in space. You know, the equivalent of a loop is like drag filling a formula over a range of cells in the grid. It's also rather a weak programming language. So in traditional programming, we've rich data arrays and records. You can define functions whenever you want. You can save your code out to GitHub and collaborate with others there. On the other hand, in Excel, until recently, we've been limited to scalar data only in cells. You know, only a number or a string could be in a cell. There's a fixed library of only about 600 built-in functions, and there's no real equivalent to GitHub. You sort of mail spreadsheets around. Still, spreadsheets are very useful and accessible and friendly, so people can build these ambitious applications, although the kind of engineering properties are rather weak, and you get a lot of duplicated formulas and copies of worksheets. And the result of all this is that although spreadsheets are very powerful, they're also unfortunately rather riddled with errors, and so we've got a litany of awkward, unfortunate headlines here. What can we do about that? Well, researchers here at MSR Cambridge about 20 years ago started to think seriously about how to transform spreadsheets into a full programming language. And one of the core ideas they came up with, and this is led by Simon Peyton-Jones, who's still in our team, it was the idea of a sheet-defined function. And here's a very simple illustration of what that might be. On the right, we've got a bit of grid that's defining an average. Here's the input, these 5 cells in B3 down to B7. And then we've got a cell over here that counts the number 5, and a cell over here that adds them up, getting 42, and a cell here that does the division to get the average. So that's an example calculation in the grid. And the idea of a sheet-defined function is we can give this a name, call it average, say. I know that already exists, but this is really just a simple example. So we introduce a new name, average, for this calculation, and say that the yellow range is the input and the green cell is the output. And then we can, if we were to do that, then we can use this new average function like any other and say equals average. And what Excel would do is take the data in B3 to B7 and sort of make a copy of the grid, put that data in there, and calculate what the output would be by calculating the whole grid, and then returning whatever is in E5. So that's the basic idea of a sheet-defined function. That was research that was done here, and about 6 or 7 years ago, the Excel team decided to pick up on this research and create a new project called Project Yellow that would try to transform Excel to eliminate some of the problems that have been experienced by people building complex spreadsheets. So the goal of Project Yellow was to remove the glass ceiling that limits the scope and reach of what a domain expert can do with Excel. And one key point was to make Excel functions reflect the abstractions of our end users by allowing end users to define new functions using ordinary formulas, like using sheet-defined functions, or indeed like using Lambda that is now available. And the second big principle of Project Yellow was to make the data values of Excel reflect the data types of our end users' domains by adding arrays, vectors, records, and even domain-specific data types implemented by third parties. So this project is well underway, and we have been collaborating with the Excel team on Project Yellow from the start. By a few years ago, 2018, we announced dynamic arrays at Microsoft's event Ignite in that year. Dynamic arrays allow a single cell to contain an array that spills out. So you see here in B5, we had a sort function that's sorting this range on the left, and the result of that spills out, as we'll see, right? So we say equals sort, that range, and the result spills from the array. And here we got a function unique that removes the duplicate values from that range. And here on the right, we've got a function filter that filters out just the names of people who are eating vegetarian food or wanting vegetarian food. So that was that was the second principle that I was talking about, of enriching the data types that people can manipulate directly within Excel. And that was announced publicly in 2018. Meanwhile, in Cambridge in 2018, our team was working hard with Excel on bringing Lambda to life. So this is a photo of taking place during discussions we were having when some members of the Excel team, Andy here and Jeff here, were visiting Cambridge, and it was Simon's birthday, so we got a nice cake, and I took a photo of the team here. And this is a nice record because Claudio was an engineer in our team at that point, and he worked really closely with Andy on implementing Lambdas directly within the product. I like this photo as a kind of gestation of Lambda in Excel. Fast forward to today, Lambda is out. It got a very positive reception from Excel users. Satya Nadella tweeted about it, and it even made it into XKCD, which is pretty neat. Why is Lambda so important? Well, I'd say there's 3 R's. R for readable. Lambda makes workbooks more readable because you can capture complex logic in a single formula. It makes your logic more reusable because once you've turned it into a Lambda formula and given it a name, it's easy to call it from other places. And Lambda also allows recursive calculations to be done inside the formula language. And so it makes the formula language Turing complete. I'm now going to hand over to Jack, who's going to tell us about the Lambda editor we're developing in our lab, which makes it much easier to develop new Lambdas.